Assalamualaikum, ladies and gentlemen. It is with great pleasure that I stand before you today to address this video. First and foremost, I would like to express my sincere gratitude to each and every one of you for gracing us with your presence. Your participation and support have made this video truly special, and I am honored to have you here. Today, I'm going to show you this video about my own studies on steel plate peak deformation variations from explosive detonation in STANAG 4569 AEP55 VOL2 steel pot and saturated sediment testing condition. First of all, let's we go to the overview first. So, landmines and explosion pose a significant threat to human life, infrastructure, and the environment in various conflict zones and post-conflict regions worldwide. The North Atlantic Treaty Organization, which is NATO, armed forces equipment must meet a minimum performance criteria under the Standardization Agreement, STANAG guidelines, which are intended to ensure a uniform standards. STANAG are processes, procedures, and conditions for a common military or technical procedures or equipment among alliance members. In NATO, there is a different types of STANAG, such as STANAG 2021, which is about military load classification of breaches, rafts, and vehicles. And next, for the STANAG 4565, like airborne multi-mode reservoir for precision approach and landing. So in this case, STANAG 4569 AEP55 VOL2 will be used as a guideline in this case. STANAG 4569 AEP55 has 3 levels, which is for the defense system. Vol 1 is about KE and artillery threat. Vol 2 is about explosive threat, and Vol 3 is about improvised explosive device threat. Hence, the standard shows the composition of the sandy gravel soil and the steel pots parameters, which are used to evaluate the capacity of different types of armor to offer the requisite levels of protection in armor vehicle. In accordance with this specification, a landmine may be buried either beneath saturated sandy gravel or within a steel pot. So, the problem is NATO STANAG 4569 AEP55 has 2 testing conditions, which is steel pot and saturated sandy gravel. In STANAG 4569 AEP55 will be used as a standard to verify armor vehicles so that they can comply or deploy ability to send to the battlefield. According to the research studies, there are variation explosion tested in a different soil or medium, which can give a different impacts. Different results are not an issue for NATO because they accept both conditions, and many prefer to use steel pot rather than sandy gravel testing condition. However, manufacturers claim to certify their test armor vehicles equally according to STANAG 4569. According to the standard 4569 AEP55 VOL2. The certification test was not known as to which testing condition was followed due to its simplicity if there is a significant variation in the test. The certification may not represent the integrity of the vehicle's safety. This study is to find out the difference between 2 testing, which in saturated sandy gravel or in steel pot condition. So we move to the we move to the measuring method. So by the instrumental method, the deformation will be measured by using a special apparatus which named a counter gauge. This tool is precise and accurate. So how to use it is, after the blasting, the steel plate needs to be loose and unbolted. Then use a counter gauge and put it on the surface of the steel plate. Next, put it on the paper and sketch it along the lines of tool. So this step must be repeated as to put into the impact block for the other result, for the residual results. Then we move to the test apparatus design. For the test apparatus design, as you can see in the figure, a small scale test frame is displayed. A test jig with dimension of 500 mm in length and 500 mm in wide and a target plate made of mild steel are included in the equipment. The 500 times 500 millimeters deformable target plate is constructed from a mild steel sheet that is 50 millimeters thick. This was fastened to a test frame that was 500 millimeters square. The design of the test device was shrunk down to 1/10 scale. The approximate weight of the test frame is 21.74 kilogram. And as you can see in the figure, there is an adjustable leg height, and adjustable leg is used for the adjusting height of steel jig, and it must be obey the standard. Must obey the standard, which 50 millimeters from the ground surface. The test jig must be put at the center of the landmine. Okay, next, as you can see at the besides of a test jig, there is a figure is about a steel plate. So this steel plate with a size 500 times 500 millimeters are known to deform under the high pressure shock waves generated by a large scale explosion or a small scale explosion. The extent of the deformation can depend on the factors such as the size of explosion, the distance between the explosion and the steel plate, and the thickness of the steel plate, and the strength and the ductility of the steel plate. In some cases, the steel plate may experience in plastic deformation, which can lead to a permanent bending or buckling. And in more extreme cases, the plate may fracture or even disintegrate completely. Steel plate will be, so to use the steel plate will be bolted under the test jig, so that it is hard to move and easily to change with a new steel plate. There are 6 plates need to be prepared for each blasting test. The plasticine will be put inside the aluminum box, which we call it as an impact block, and compacted it. Then the impact block is bolted above a steel plate above a steel plate, and then for each experiment, the plasticine must temper it again. Let's move to the explosion charge. So for the type of the explosive charge will be used is AN emulsion, which is ammonium nitrate emulsion. So to prepare as in the figure, so first of all, the AN emulsion is being cut into 20 grams and put it into a cardboard. So after that, we compress it until the shape will be just same like as in the figure. So this step will be repeatedly for the next blasting. Next, test setups. So in the test setup, there is a 2 testing condition must be prepared. So for the sanding gravel test setup, the step is for the step 1, step 2, step 4, and step 5 as in the figure. And for the steel pot test is for step 1, step 2, step 3, step 4, and step 5. Okay, first of all, for the sanding gravel, for the step 1, a timber box must be buried on the same level as the ground as in the figure. A plastic bag needs to be put in the timber box to avoid the water coming out during the compaction. Then for the next step is sanding gravel pour into the box until it full, and it was compacted by pouring water over the sand and tapping on its surface. Make a small hole at the surface of it as to put a 20 gram of landmine on it. For the step 4, put a test jig apparatus setups with a steel plate and impactor box that has been bolted at the top of landmine, and make sure the test jig at the center of it. And for the last step is the center of the target plate must match the location where the explosive charge was buried in the test bed. The spirit level tool need to be used so that the test jig is always at the center and to avoid the error data. The error setup may affect the data. For the steel pot, to set up the steel pot apparatus, place the steel plate on the place the steel pot on a sturdy and level surface. Put a 20 gram landmine on the steel pot as shown in the figure. making a square hole as to put the steel pot inside of it and make sure the position steel pot above the steel plate is center and stable. So for the result, as you can see, there is a comparison testing between the steel pot and sanding gravel testing condition. So for the steel pot testing condition, there is a 3 testing: TSP1, TSP2, and TSP3. So as in the figure, it shows the different testing steel pot condition between TSP1, TSP2, and TSP3 in peak deformation. From the testing 1 to 3, the data shows steel pot decreases from 60 mm to 30 mm and increases from 30 mm to 14 mm at TSP2 to TSP3 in residual deformation, while peak deformation has reached its maximum from 22 mm to 25 mm and it decreases to 24 mm at TSP3. Perhaps the TSP2 has the highest peak deformation, which reached 25 mm, while TSP1 has reached 60 mm in residual deformation. The good condition and a perfect setups may influence the good data. So the TSP3 has reached its apex at length of condition was 20 mm, while the others at 25 mm as the center. It shows the peak and residual location are not at the center of the target apex. It is causes of not proper setup, where the position of test jig is not at the right center of the steel pot. Furthermore, TSP3 still can produce a perfection data with its peak deformation at 24 mm and residual deformation at 14 mm, which approximately as other tests. For the sanding gravel, it shows the different testing for gravel soil condition between TSG1, TSG2, and TSG3. Based on the graph, the height of peak deformation is greater than residual deformation from TSG1 to TSG2. The data shows the peak deformation rapidly slope and decline from 25 mm to 22 mm, while residual deformation is 7 mm at both. Hence, TSG3 has reached its maximum peak deformation at 27 mm and has the highest residual deformation at 10 mm. 10 mm. So TSG2 is the dropping 4% from TSG1 because of an error setup. The density, compaction, and condition may influence the data. It is because the bolts are loosely attached. During the blast, steel plate is less absorbing the impact caused by some free space it has and transfers more to the impact block. However, even TSG2 has a less peak deformation than others, it still produces a good and complete data. Okay, so for the conclusion is, in terms of peak deformation, TSG1 is greater than TSP1 by 2.79%. As for the test 2, TSP2 is greater than TSG2 by 5.48%. Lastly, for the test 3, TSG3 is greater than TSP3 by 2.69%. So from all these tests, we can conclude in terms of peak deformation, TSG is greater than TSP with difference average 3.65%. In terms of residual deformation, TSG1 is greater than TSP1 by 5.39%. As for the test 2, TSP2 is greater than TSG2 by 1.59%. Lastly, for the test 3, TSG is greater than TSP by 3.8%. So from all these tests, we can conclude in terms of peak of residual deformation, TSG is greater than TSP with difference average of 3.59%. In terms of peak acceleration, TSG also is the greater than TSP1 by 2.79%. As for the test 2, TSP is greater than TSG by 5.48%. And lastly, for the test 3, TSG is greater than TSP by 2.69%. So from all these tests, we can conclude that in terms of peak acceleration, TSG still is the greater than TSP with difference average for 3.65%. In peak and residual deformation, sandy gravel, we have known that sandy gravel is higher than steel pot because of sandy gravel is more prone to deformation and has lower resistance to applied loads, hence exhibits lower elasticity due to its granular nature and lack of cohesive forces between particles. For the peak acceleration, sandy gravel also becomes the greater because of the craters that were formed during the blasting. The reflected or the diffracted blast waves from the crater edges can interact with the plate and generate secondary pressure waves, which can influence the overall deformation patterns. When the above ground structures are forced upward during the blast events, the effect of ejecta may not be as critical compared to the blast wave itself. So I think that's all from me. Thank you very much for watching this video.